And where we are working towards is the following. Ons gaan nou kyk na wanneer jy 3 verskillende voorwerpe het. Okay? En dan gaan ons vectorsomme doen. You guys remember vector sums. It's the same as if we have a box and one person pulling it to the left and the other one pulling it to the right. How do you work out the net force? You have a sign. You pick a side as positive. So jy gaan moet kyk. As ek kyk na hierdie punt, wat gebeur? Trek hierdie ene hom aan of stoot hy hom af? As hy hom aantrek en jy kies in daai rigting as positief, then that will be your positive value. If you have something else, pulling it to the other way or pushing it to that way, just keep consistency with your sign. So ons gaan met vectorsomme werk, waarmee ons al gewerk het, maar ons gaan nou net met elektrostatiese kragte werk. Okay. So met ander woorde, sê nou maar ek het hierdie 3 punt ladings and that's in 1 dimension. That should be ominous to you guys, that they have to specify that this is in 1 dimension, meaning that we will soon move to 2 dimensions. Which you have done as well. Hoe weet ek julle het dit gedoen? Want ek het dit met julle gedoen in die klas. How do we work out the net force in 2 dimensions? Dis daai ding van Pythagoras en tan, nie tan nie. Tan, la. It's the same thing. It's a different type of force, but we're still working with forces. Okay, maar ons gaan vandag net eers kyk na 1 dimensie. So let's say you have those 3 objects and they give you the distance from J to K and they give you the distance from K to L and then they can say what is the net force experienced by K. Dan moet jy gaan kyk wat is die krag van J op K, wat is die krag van L op K en mooi kyk is hulle besig om aan te trek of af te stoot. So kom ons gaan. Hulle sê vir jou bestudeer die stelsel van swere wat elektrostatiese ladings het. Do you guys see? If we are going to work out the net force on K, so die netto krag wat deur die punt K ervaar word. Write it like this. If J on K, in which direction will it be? Na links of na regs? Ignoreer L. Hoekom na links? Aantrekkende krag. So it's pulling it towards it. Ignore this. Just look at that. Let's say this point is fixed. Hierdie ene is los. Na watse kant toe gaan daai punt beweeg? To the left. Why? Because this has an attractive force between it. Stem julle saam? So met ander woorde, kom ons vee nou eers al hierdie gemors uit. The direction of the force on K due to J. Sien julle, ek sê J op K. So die krag wat J op K uitoefen is na links. Stem julle saam? What would the force on K be due to L? To the left or to the right? Na regs. Hoekom na regs? Because let's say, imagine for a second, and that isn't necessarily true, but let's imagine for a second that this one is fixed and this one is loose. In watse rigting gaan hy beweeg as ons heeltemal vir J ignoreer? It'll move to the right. Why? Because this is negative and this is positive. So wat gaan ons dan doen? Ons gaan 'n rigting kies as positief. And we're going to say, let's say, to the right as positive. So this one will be negative and this one will be positive. And F net is la la la. And that's what we're going to do now. Okay. So jy gebruik die tekens van die ladings om te besluit. Trek hy hom aan, met ander woorde, sy krag is na daai rigting toe, of stoot hy hom af, met ander woorde, daai krag word ervaar weg van hom af. Got it. Kom ons doen dit. Teken en benoem 'n vrye kragte diagram om elk van die elektrostatiese kragte wat op K inwerk voor te stel. And there you have it. Nee, puntlading, bla bla bla. Bereken die netto elektrostatiese krag op K. So what they said is take to the right as positive, which happens to be exactly the same as what we did. Do you guys see when we are working J on K, I completely ignore L. So jy vat een stukkie van die stelsel, werk hom uit, en dan vat jy 'n ander stukkie van die stelsel, werk hom uit. En eers daarna konsolideer jy die twee met mekaar. So only after that you say this one will have a positive value, This one will have a negative value. Let's go. Sien julle ook dat ek glad nie nou tekens hier instel nie. Once again, I'm only looking for the magnitude. Nee? Ek gaan nou maar, wanneer ek in die netto krag werk, gaan ek worry oor of het positief of negatief is. Okay, so they substituted there. Do you guys see the times 10 to the power of negative 6 because it was microcoulomb? So now we know that the force on K due to J is 240 Newton. And we know that it will be to the left. Goed. Ek is nog steeds bezig met wat die hele tyd? Wie se wet? Nog steeds die hele tyd bezig met Coulomb se wet. Maar nou werk hy net met meer as 2 op 'n slag. Same here. Stel hom in, werk hom uit. Ek moet ook vinnig dit ook sê. Just be wary when you are substituting the distances between the two. Kyk net mooi hulle afstande verskil. Okay. En dan gaan ons sê ons neem reg as positief. So F net van K is minus plus, wat beteken dis negatief 120 Newton. And then you just have to remember which one you picked as positive. So ons het na regs gekies as positief. So as ons 'n negatiewe antwoord kry, beteken dit die rigting van ons netto krag is na links. And it's as easy as that. And you guys have been doing this for more than a term, né? As iemand trek en die ander een trek in die teenoorgestelde rigting, dan kies jy 'n rigting as positief. And you just have to keep consistent with your signs. Okay. Goed, ek kan nog maar gou nommer 3 vir julle wys. Hulle vra vir jou, wat is die elektrostatiese krag wat K op J uitoefen? So remember, that's the same as Newton's gravitational law. If one thing exerts a certain force on an object, then that object exerts a equal but in the opposite direction. Why? Who said that? Ook Newton, nog al die pad oom Newton, né? But this one will also be in the same direction because if the one is an attractive force, then the other one will be an attractive force as well. Okay. Ons gaan nie vandag hierdie doen nie. Okay, but I'll show you guys what we are working towards. Kyk gou vir my, ons gaan nou werk op oplading S. Okay. Vergeet van R, kyk net na P. In watse rigting gaan S beweeg as gevolg van P? Once again, imagine that this one is fixed and this one is allowed to move. That isn't what's happening, but let's imagine that. Stimulus om hierdie ene gaan opwaarts beweeg. And then we can calculate what the force will be. Okay? En dan doen ons die teenoorgestelde. Wat sal hierdie ene doen met daai ene? Na links of na regs? Nee. Na links. Sien jy, trek hom aan, teenoorgestelde ladings. So then that will be your triangle. Pythagoras to find that, and the force will be in this direction. Somewhere between north and, what's that, west. Okay? Jy kan nog steeds op dieselfde asse werk. Okay. Which we have done, but we're not going to look at that today. Goed. Ek dink wat ons nou kan doen is